Hello everyone, today we are talking about parallel and perpendicular lines. By the end of this lesson, you should be able to write the equations of lines that are parallel and perpendicular to any other given line. With this idea of parallel and perpendicular, why don't you take a sec, pause the video, and compare these maps of Washington and Manhattan. So hopefully you paused the video and brainstormed as many similarities and differences between these two maps. So personally, by looking at the Manhattan map, I notice that whenever the streets are named by sort of number, they're always parallel to one another. That means that they run along one another. We see the same thing in Hamilton streets. I know there's a West 4th, West 3rd, West 2nd, and West 1st. You may have also noticed that these orange lines run perpendicular to these gray lines, which means they sort of intersect at right angles. The other thing you may have noticed that with, I guess, the exception of Broadway, most of the lines in Manhattan are either parallel or perpendicular to one another. If we compare that to Washington, well, there's still a lot of parallel activity going on. We have 28th, 29th, 30th, those are parallel. And some of the orange streets are also acting as perpendicular lines to those parallel numbered streets. But there's also some sort of different lines going on around this DuPont circle, and also if we look at the north end of this map. You probably noticed many more things than I did, but those are just a few that I noticed right off the bat. What I want you to do before watching the rest of this lesson is go check out the investigation on parallel and perpendicular lines that is available on the hub. If you want, you can work with a partner, but maybe do it through FaceTime or text. So pause the video and go do that now. Before we get into it, we need to sort of define what a parallel line is. Well, a parallel line in mathematics is defined as two lines that will never cross. We know that they will never cross in that they have the exact same slope. So their m value will be the same. So, for example, maybe their m value is -2. Or it could be 2, or 4, or 38/9. It doesn't matter what the value of m is as long as it's the same. You may also notice that the initial value or y-intercept of both of these lines are different. Perpendicular lines, on the other hand, cross at some point and always cross at a 90-degree angle. We can tell that they're perpendicular, or that they would have a 90-degree angle when they cross, when the product of their slopes is -1. So what that means is we would be able to multiply slope 1 by slope 2, and that would give me -1 as an answer. That's how I can tell it's perpendicular. Another way of saying that is negative reciprocal. So the slopes are negative reciprocals of one another. That's a very important piece of terminology. What it basically just means is that the product is -1. To start off, we're going to practice by finding the negative reciprocal of each of the following. Now, the easiest way to think of negative reciprocal is to step 1, flip the number, which in our case of A would be 3/2 becomes 2/3. And because it says negative, we're going to flip the sign as well. Initially, we started out as positive, which means if we flip the sign, we're going to be negative. So the negative reciprocal of 3/2 is -2/3. So another way of saying reciprocal is actually inverse. So when I say flip or opposite, that's kind of what it means, the opposite fraction. So like I said, The easy way is to flip the fraction and flip the sign, but we can actually calculate this. So the negative reciprocal of a number is to take -1 and divide that by the number. So we have 1 divided by 3/2. Now when we have a number divided by a fraction, in order to get rid of that sort of fraction, what you're going to do is end up multiplying it by the inverse. So we flip that fraction, so it becomes 2/3. And if we take -1 times 2/3, that becomes -2/3. You'll notice that's the exact same thing we got over here. So this is just sort of why we're able to take the flipped fraction. This is sort of the mathematical steps. Just you can do it quicker by thinking of it that way. So if for some reason you were asked to calculate the negative reciprocal and show your work, these would be the steps you take, but for the most part, we would be satisfied with you simply providing the negative reciprocal. So let's move on. The negative reciprocal of -1, if we flip the sign, we know that it's going to become positive because it initially started out as negative. Then, because this 1 is currently over an imaginary 1, we're going to flip that equation. So our -1 becomes +1. We can check this work by taking our -1 times 1, and that will give us -1. If it gives us -1, we know that we have done it correctly. Let's check the work we did up top. So 3/2 times -2/3 gives us 3 times 2 is -6, 2 times 3 is 6, and likewise that gives us -1. Okay, let's move on to B. So likewise, that 2 is over an imaginary 1. So if we do the reciprocal of that fraction, it's going to be flipped and become 1/2. We also have to do the opposite sign. So here, it's a positive, and the opposite of that is going to be negative. If we want to check our work, we can take 2/1 times -1/2, which becomes -2/2, which is equal to -1. So once again, we found the negative reciprocal. And finally, let's find the negative reciprocal of -4. So again, that -4 is over an imaginary 1. If we take the inverse of that fraction, it's going to be 1/4. We also need to flip the symbol, so that negative becomes a positive, which means this is our negative reciprocal. Okay, so here's a question. Here are two equations of lines, and it wants to know if they're parallel or perpendicular. So in order to solve this problem, we need to remember our definitions of parallel and perpendicular. And I've written them up there. So I'm going to start off with looking at the slopes, because you'll notice both parallel and perpendicular depend on the slopes. You'll notice that the slopes of each are -4. So because the slopes are both -4, I can say that it is parallel. And I've just written a little statement down here to explain that. So because M1 is equal to M2, the slope is parallel. If you were asked to sort of show your thinking or show your work, you would be expected to sort of identify that you can tell what the slope is, and then make some sort of statement regarding how you know or how you used the slopes to solve whether it was parallel or perpendicular. Okay, here's another problem. So I notice that for m1, the slope is 3, and for m2, the slope is negative 3. So I know it's the same number, but m1 is not the same as m2, so it cannot be parallel. And I've written a little statement up here saying that. So m1 is not equal to m2, so it's not parallel, which means our next option is perpendicular. If you recall, in order to prove two lines are perpendicular, their slopes are negative reciprocals of each other, which means if we take m1 and multiply it by m2, it needs to equal negative 1. Okay, and I've just moved that little statement up there. So, what you'll notice is that 3 times negative 3 is actually equal to negative 9. So, because the product of the two equations is not negative 1, it means they're not negative reciprocals, so the answer is actually neither. And I've just written a little conclusion statement down here. So because the product of m1 and m2 does not equal negative 1, the equations are neither. Okay, here's another problem. Why don't you try and pause the video and see if you can give it a try. If you're not ready for that yet, then just keep watching. So, right off the bat, I notice that the slopes of m1 is 1 over 5, and the slope of m2 is negative 5. So because the slopes are not the same, it cannot be parallel, which means our options now are perpendicular or neither. So in order to solve or prove whether or not it's perpendicular, what I'm going to take is m1 and multiply it by m2. If it equals negative 1, then they're negative reciprocals, and I know that it's perpendicular. So m1 is 1 over 5, and m2 is negative 5. If I wanted to multiply these, I can imagine that there's a little imaginary 1 over there, which leaves us with 1 times 5, well, negative 5, and 5 times 1 is 5, 5 divided by 5 is negative 1. So, therefore, because the product of m1 times m2 is equal to negative 1, I know that these problems are perpendicular. And I've just written a little sort of conclusion statement. Therefore, because m1 is a negative reciprocal of m2, they are perpendicular. Oh boy, here's a bit of a tricky one. I want you to pause the video and see if you can figure it out on your own. It might help to graph it. Okie dokie then. Let's say you pause the video. So there's a few ways you can do this. I suggested that you graph it, so why don't we do that? So if we have a Cartesian plane, then y is equal to 2 is going to be, I don't know, somewhere around there. And x is equal to 3 is going to be somewhere around there. Okay, so we have a vertical line and a horizontal line. That means that it's definitely going to be perpendicular. The question is, how do we prove that mathematically or algebraically? Let's look at the slopes. So the slope of m1 is, well, it's a horizontal line, so the rise is 0 and it's over some number. Okay, so that means that our slope is 0. If we look at the slope of our second equation, so m2, well, our rise is sort of some variable over 0. But because we can't have 0 as the denominator, we say that this is undefined. So our first slope is 0, and our slope of our second equation is undefined. Now, we've said before that when two lines are perpendicular, their slopes are negative reciprocals of each other. So the negative reciprocal of this is negative 0 over a, which is just 0. Basically, what you're going to need to remember is that vertical and horizontal lines will always be perpendicular, and their slopes, one will have a slope of 0, and one will have an undefined slope. So if I had asked you to give me the perpendicular line of x is equal to 8, well, the slope here is undefined, which means I just need a slope of 0, and I could pick any number. Let's go with 20. And so these two would be perpendicular, because one's a vertical line with a undefined slope, and one's a horizontal line with a slope of 0. Okay, here's our final practice problem. Can you determine the equation of a possible line that is perpendicular to y is equal to negative x plus 7? Pause the video, give it a try. Okay, let's assume you paused the video. So it says that it wants it to be perpendicular, which means that I need to first find the slope. So our slope of m1 is equal to negative 1. In order to find the slope of m2, I'm going to take the negative reciprocal. So the negative reciprocal of negative 1 over 1 is, I'm going to flip the sign so it will be positive, and 1 over 1 is still 1. So that means that a perpendicular line would have a slope of 1. So if I'm going to rewrite this equation, I could write y is equal to x. And if I wanted to, I could sort of write any b value. And let me show you why. So if we have a graph and our, let's pretend that y is equal to negative x. So it's negative, which means it's going to be pointing up and back. And it has a slope of 1. So it's, and it also goes through positive 7. So here we have it going through, let's say that's positive 7, and it's going up and back. If we have a perpendicular slope, so this guy right here, this guy will look something like this, which is, if I had drawn my lines properly, would be a perpendicular slope. If I wanted to, I could create y is equal to x, so the slope is the same, plus 2, in which case I would just draw a parallel line running through 2. It's still perpendicular. Or I could draw y is equal to x minus 5. And once again, because that slope is the same, I'm going to be drawing a line that's perpendicular to that original green one, this original green one right here, and all three of these are perpendicular to our original equation of the line. The reason being, the slope is the negative reciprocal. So lots of different answers for this. Choose whichever one you like best. Now that we've worked through the lesson together, give the homework a try. Remember, ask your teachers if you need any help.